Assalamualaikum warahmatullahi wabarakatuh. Today, we will present our water tank design for our project. The proposed pipe diameter is 300 mm. The proposed material of the pipe is steel reinforced high density polyethylene HDPE. The advantages of this material is flexible plastic pipe. So it's very suitable for our project because our project has different elevation from the reservoir to the parcel A. Okay, and then also to replace aging concrete or steel main pipelines. Then it also has high level of impermeability, and then it also has strong molecular bond, which is make the pipe is stronger and can cater high pressure of water from the reservoir to the parcel A. And lastly, it also suitable for high pressure pipeline. So it's very suitable for our project because the pressure from the reservoir to the parcel A is very high.
Now for the peak flows and firefighting flow scenarios, we have the Q total for parcel A, which is 1,405,416 liters per day. For peak flow, we have to times by 2.5, so we will get 3,513,440 liters per day. For fire flow, we have the fire risk plus the water demand, which is 3,888,000, which we'll get from the Class B from the NWA guidelines, which is equivalent of 2,700 liters per minute. So we plus that with the Q total, and we'll get the 5,293,416 liters per day. Since our fire flow is larger than the peak flow, we have to pick the fire flow as the Q design.
After the design flow is known, we can proceed with the head balance method (HBM). For the first step, we must assume for each pipe using the flow design that we get. From that, we can apply continuity equation at each node. We have to make sure that Q in and Q out are the same value. We can assume that positive is the right direction and each flow is a by loop. From there only, we can know the direction of the flow. If the value of Q is negative, it means the opposite flow direction. For this project, we have 3 loops in order to get HBM.
Next, we transfer the data to the tables and find the key value. Since for this project, we apply Hazen-Williams equation to determine head loss, which is H is equal to K times with Q to the power 1.852. Then K is equal to 10.69 times with L divided by D to the power 4.87 times with C to the power 1.852. We determine K for all loops, and since we have K and Q value, so we can calculate the head loss value. And then after we obtain the H value, then we need to check for all loops whether the summation H is equal to 0 or not. In our project, iteration 1, the summation H is not equal to 0, so we need to do another iteration or next iteration, but we need to do correction first. We apply the correction to determine Q prime, which the Q prime will be our new Q for the next iteration. And we did until iteration 7, where the H summation and delta Q is equal to 0.
Alright, now we look at the residual head. So from the figure here, we will know the friction loss in each pipe. So with the given elevation head, now we can calculate the H, where the H given formula is available H naught minus with the friction loss. So to get H naught, we use this formula and minus out with HF so that we can find the value of H. Then for the TWL and HSL, we'll be using in the available H naught formula. And then lastly, we will get the residual head. Alright, so now come to the last part of the presentation where we need to see the water tank reservoir design. So we have calculated that the total daily demand is 15 million liter per day, which is likely about 15,880 meter cube, and the land area available is 40 times 90 meter. So we have proposed the tank area of 2,400 meters square with a depth of 7 meter and a height of 25 meter. In conclusion, the design of this water tank is able and enough to cater the water supply or the water demand for each block and for that area. Thank you so much.